Welcome to the first video of my YouTube channel. Sorry for the clickbait title. This is my first video, as I said, so I'm trying to get promoted out there. Yeah. I actually am. I do work for one of the quote-unquote FAANG companies. I'll do a 1 subscriber special and tell you which company I work for if I get 1 sub. So basically during these videos I will be doing LeetCode problems to help you learn LeetCode and get a good job, or get a quote-unquote good job. So let's jump right into it. And so basically you can pause the video and try to do it yourself, or try to follow along if it's too hard. This right now isn't easy, so it shouldn't be too hard, but don't be afraid to pause it or rewind or fast forward. Okay, let's jump into it now for real. So number 1, toSum. Given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So the example they give here is the input is 2, 7, 11, and 15. Target is 9. So index 0 plus index 1, 2 plus 7 is equal to 9. They return the list 0, 1. Okay, so right off the bat we can come up with a very quick brute force solution, which would be just to add up all the numbers accordingly, like 2 plus 7, and then 2 plus 11, 2 plus 15. Well, in this case, 2 plus 7 would give us 9, and we'd find it. So that would be very quick. But what if the target was 26? Then we'd have to go all the way to 11 plus 15, which would take quite some time. The time complexity would be O of n squared, I believe. So yeah, that's not very good. But we can actually do it in O of n time using hash maps, or in Python dictionaries. So what I'm thinking is that we can enumerate through, or iterate through, the list of nums that we have, and subtract and get the difference of target and that number, put it into a dictionary, and then check if that numbers in the dictionary is one of the numbers in the nums. And therefore, since there has to be one solution, this can be done in O of n time, which is basically just one iteration through the list. So let's go about implementing this. What can we name our variables? Always the hardest part. Let's call it num map dict, int. Make sure you use type hinting. That is it's actually very important if you start a job, and it helps a lot with code readability. Dict int is equal to. So we make an empty dictionary right off the bat, and then we can begin to iterate through the list. So for idx, num in enumerate nums. Oh, so for those of you who don't know, you can do, normally if you do for num in nums, you can iterate through the list, but you will not be able to get the index. But Python has this helper function called enumerate, so you can do for index, num in enumerate nums. So that should return the index and the value of that specific iteration. So for index, num in enumerate nums, what we want to do is diff is equal to target minus num. So this is going to be the difference between the target and that specific value. So let's say, going back to this example, on the first pass, no, first iteration, I guess, the target is 9, the number num is equal to 2, so diff would be equal to 7. So from there we can check if diff is in our num map. So if if diff in num map, right, then we can, if diff is in the num map, that means it is found. So therefore we would be done. So we were to return num map diff and index. Oh, and my bad, I wasn't even that clear with my documentation. So this is going to be an int and an int, with the key being the number, and the value being the index located. That's not really good documentation, but it will do for now. So therefore, let's go through our code for right now. So we create an empty dictionary, then we iterate through the list. We get the difference, which is a target minus a num. So if diff is in our num map, that means our previously iterated through numbers. Then we return the index of diff and the current index of our number. So what happens if diff is not in our num map? Then what we do is we add it to our we add it to our num map. Sorry, I don't know what happened. Num map diff is equal to index. Right? Okay, so let us run through this program by hand using the example given. So let's say it is 2, 7, 11, 15, and target is 9. So there's an empty dictionary. Empty. So for index in num is equal to enumerate nums, diff is equal to target minus num. So first of all, index is going to be 0. Index is equal to 0. Num is equal to 2. Diff is equal to target minus num. So diff would be equal to target minus num. Target is 9. 9 minus 2 is equal to 7. Diff is equal to 7. If diff in num map, our num map is empty right now, so diff is not in num map. Okay, let's go to else. Num map diff is equal to index. So therefore our num map will now have the value 7, 0. Okay. Then for the next iteration. Next pass for the next for thingy. So index will be equal to 1. Number will be equal to 7. So diff is equal to target minus num. Diff is equal to target minus num. Target is still 9, but the number here is 7. So diff will be equal to 2. If diff in num map, see, here is a mistake. Yeah, in the example, this should have completed the if loop, if statement, and returned. The thing that was wrong was, instead of marking diff as the key, and index as a value, we should have marked num as a key and index as a value, because it is the num map after all, not the diff map. That is why you always should go through it in your head before running submit, because it's good practice first of all, and then you don't look silly when you name it num map but you actually fill it with diffs. So let us try again from the beginning. So dict is empty, so index is equal to 0, num is equal to 2. Diff is equal to 9 minus 2, which is 7. 7 is not in there because it is empty. So num map num is equal to index. So therefore we add 2 colon 0. The next iteration, index is equal to 1, num is equal to 7. Diff is equal to target minus num. Diff is equal to 9 minus 7, which is equal to 2. 2 is in here, so we return num map diff, which is 0, and index, which is 1. 0, comma 1. Which is expected return for this example. And now let us run the code. Cool, it worked in 40 milliseconds too. Let's submit it to make sure it passes all the test cases. And 44 milliseconds, faster than 95.83% of Python's online submissions. See, when it runs faster, it's because other people probably used the brute force method, which would obviously take longer. But see, this used more memory than 58% because it had an added hash map to it. Normally there's a trade-off between memory and speed. Speed is always, I'd say in most cases speed is more important, because for memory you can just plug in extra like memory and stuff, but for speed you're never going to get back those like 5 milliseconds or whatever. And this might seem like minuscule, like, oh, it's only 5 milliseconds, but when you're running like billions and trillions of data items, like when you're working at large scales like all the large companies do, that can add up to a lot. And like extra hard drives or whatever, RAM is like only like 100,000. It could be like only like a few $1,000s at most. But like a day of productivity, if you're running your program and you're trying to brute force everything, yeah. So 9 times out of 10, speed is more important than memory. So I hope you learned something. If this is shorter than 10 minutes, I will probably make it up to 10 minutes for the YouTube algorithm. This is my first video. Please like and subscribe, and I plan to make at least a video a day if I have time. I still have like a job and stuff. But yeah, please like and subscribe and comment. And if you have any requests for problems that you want, send me a link. And if they're not private, I'll try to do them. I don't have LeetCode Premium, so like, yeah. Okay. See you later, alligator.